power, promise, and plenty of problems. These engines looked strong and ready for any task, but real-world use told a different story. Unexpected failures and poor performance left operators frustrated and slowed down work. Every day in the field could bring a new problem, testing patience and skill. Here are the 12 worst 80s tractor engines ever made. Number 12. Perkins 1006.6. Even well-known brands can produce engines that make farmers' lives harder, and the Perkins 1006.6 was one of them in the 1980s. This engine was supposed to power mid-sized tractors, yet small problems became constant annoyances. Operators often faced issues that slowed work and demanded constant attention. From the first day in the field, it showed that minor failures could pile up into serious frustration. One major problem was leaks and poor sealing. Oil often seeped from gaskets, and small cracks allowed fuel to drip, forcing unexpected stops. In the middle of these problems, the engine's displacement of 6 liters, which is 365 cubic inches, mattered because the size created more pressure on the seals and gaskets. The larger the engine, the more stress the components experienced, which made leaks a common complaint during long field operations. Another significant issue was inconsistent power delivery. Horsepower reached around 110, but the fuel system often failed to maintain it. Worn injectors or clogged lines caused tractors to lose strength at crucial moments. This meant plowing or hauling heavy loads became unpredictable, turning ordinary tasks into difficult and time-consuming work. Torque, which could reach about 260 pound-feet, often dropped under load because the engine could not maintain proper fuel pressure, leaving tractors struggling in the middle of fields. Vibration and overheating were additional problems. While the engine allowed tractors to move at speeds near 19 miles per hour, prolonged use caused shaking and rising temperatures. In the middle of this strain, manifolds and small engine components would sometimes crack, and oil could leak more severely. These issues made it risky to push the engine for long periods, forcing operators to slow down and constantly monitor performance. Fuel efficiency also contributed to frustration. The engine normally used around 6 gallons per hour, but even slight neglect or wear could increase this number. Filters and pumps clogged easily, making fuel use higher than expected. In the middle of fieldwork, this meant more frequent refueling stops, reducing productivity, and adding to the constant irritation caused by the Perkins 1006.6. From leaks to power loss, overheating, and poor fuel efficiency, the Perkins 1006.6 caused repeated problems that made ordinary farm work harder. Farmers often found themselves spending more time on repairs and maintenance than on actual field work. Every day in the field reminded operators that this engine required constant attention to avoid serious issues. Its reputation in the 1980s came from the frustration it caused rather than any strength or reliability, leaving a clear mark as one of the worst engines of its decade. Number 11. Deutz BF4L 913. In the early 1980s, Deutz engines were supposed to show strong German engineering, but the BF4L 913 quickly caused trouble for others. This engine had some very unusual habits, but the main problem was its air-cooled design. This made the engine highly sensitive to dirt and dust. When working in dusty or muddy fields, the cooling fins could get clogged with dirt, causing the engine to get too hot. Without a liquid cooling system, it could not handle the high heat from long, hard work, especially in messy or dry conditions. This weakness often turned simple tasks into stressful work, with operators needing to watch the temperature constantly to avoid damage. The engine had a displacement of 4,100 cubic centimeters, which is 249.3 cubic inches, a size that should have been enough for medium-sized tractors. The power output matched its size, but farmers often felt it did not have steady strength for heavier tools. Horsepower was around 90, yet the engine often felt weak when pulling through thick soil. Its design, while simple, lacked the strong, steady pull that modern liquid-cooled engines provided. Even ordinary work could become difficult, with tractors struggling when they should have been moving smoothly. The air-cooled design caused more problems in real life than the designers had expected. Because it relied on air, it was less durable than other engines. Operators often had to stop and clean the cooling fins, which wasted valuable work time. Tractors could reach a top speed of about 16 miles per hour, but the engine's unreliable behavior made it hard to maintain a steady pace. Torque reached roughly 235 pound-feet, which looked fine on paper, but it often failed to give a smooth, constant pull during long hours in the field. Fuel use was also a constant worry. The engine could drink a lot of fuel, especially under heavy work. Mileage could drop to around 8 miles per gallon when working hard. Another big problem was the air filter system. If it was not cleaned or replaced on time, dirt could get inside the engine, causing early wear and damage. The BF4L 913 showed that even a bold or clever design could be a headache if it ignored simple practical features. Its air-cooled system and other weak points made daily work stressful and unpredictable, leaving farmers dealing with breakdowns at the worst times. Number 10. Kubota V4300. The Kubota V4300 was meant to be a reliable workhorse for medium-sized tractors, but it quickly earned a reputation for frequent and unpredictable failures. Farmers often faced a variety of issues, from oil pressure drops to sudden stoppages. Although designed to be modern and efficient, its complex construction often caused surprise breakdowns. Many operators actively avoided tractors with this unit, showing how its lack of dependability affected everyday farming. Its displacement measured 4,300 cubic centimeters, which equals 262 cubic inches. This capacity was intended to provide enough strength for demanding tasks, yet uneven power output became a common frustration. Rated at 81 horsepower, the unit frequently failed to maintain steady performance, causing tractors to slow on hills or struggle through heavy soil. In daily work, inconsistent strength turned routine tasks into frustrating delays. Internal design flaws caused additional problems. Oil leaks appeared more often than expected, sometimes leading to serious engine damage if not noticed quickly. Operators had to constantly monitor oil levels, adding extra steps to long workdays. Torque reached roughly 159 pound-feet, which seemed adequate but rarely delivered smooth pulling power. At slower speeds, tractors would lose momentum, forcing frequent gear changes to keep implements moving. Fuel efficiency also fell short of expectations. Average mileage was around 12 miles per gallon, but heavy workloads could reduce this further. The V4300 struggled with high fuel use, making it more expensive to operate than similar models. Frequent oil consumption added to costs, and problems with the air and fuel systems often accelerated wear. Even basic tasks required constant attention, showing that a bold design without practical reliability could turn work into a test of patience. Overall, the engine became notorious for its unreliability. While it could handle simple chores, long-term use revealed weaknesses in durability and steady performance. Farmers learned that tractors equipped with this unit demanded constant supervision, and small problems often worsened into larger ones. In the 1980s, the Kubota V4300 left a lasting impression as an engine that made everyday field work harder than it needed to be. Think these were bad? Just wait, because the next ones are even worse. Hit like, subscribe, and see them all. Number 9. Fiat 611. During the 1980s, tractor makers were racing to build stronger engines for bigger farms and heavier equipment. Fiat wanted to keep up with this trend, and the 611 was introduced as a modern engine for medium and large tractors. Farmers had high hopes, expecting it to handle long hours in the fields. Instead, the unit quickly became known for causing constant trouble. Operators often faced uneven performance, high maintenance, and unpredictable failures. Unlike older engines from Fiat that were easier to trust, this one often let tractors slow or stall, turning ordinary work into a constant challenge. The 611 was a six-cylinder engine with a displacement of 5,500 cubic centimeters, which is 337.15 cubic inches. This size was meant to give enough strength to pull heavy tools and complete demanding tasks. Horsepower was rated at 90, yet in real work, the engine often failed to deliver steady output. Tractors slowed when moving through thick soil or climbing hills, making everyday farming tasks take far longer than expected. The uneven power added constant pressure on operators, who had to keep adjusting to maintain progress. Oil consumption was another major problem. The engine used oil quickly, forcing operators to check levels multiple times a day. Torque reached roughly 350 pound-feet, a figure that seemed strong but rarely translated into smooth pulling power. At lower speeds, tractors would lose momentum, which meant workers had to change gears repeatedly. These issues made long days in the field tiring and frustrating, as even simple jobs required constant attention. Repairs and upkeep were not simple. Many small problems needed special tools or extra knowledge to fix, making maintenance more complicated and costly than farmers expected. Fuel efficiency was weak as well. Normal use returned about 11 miles per gallon, but heavy workloads reduced this further. Operators had to be careful with speed to prevent sudden drops in power, turning routine chores into a constant test of patience and attention. Today, the Fiat 611 is remembered mainly for its repeated failures and lack of reliability. Despite being designed to be powerful, it often slowed work and added extra stress to daily tasks. Operators quickly learned that long hours in the field often turned minor issues into bigger problems. Its inconsistent power, high oil use, and tricky maintenance made it one of the more frustrating engines of the 1980s. Even though it was built to be strong, it demanded constant care, leaving farmers wishing for a simpler, more reliable engine. Number 8. MWMD 226-4. In the early 1980s, farmers expected European tractors to be steady and reliable, but the MWMD 2264 often proved to be the opposite. Operators found that normal field work like plowing or hauling became unpredictable. The engine's power would drop unexpectedly, forcing them to constantly adjust speed and gears to keep implements moving. Even short tasks could turn into a struggle, and the tractor required almost constant attention during long days. Operators noticed that the engine often struggled under heavier loads, making even routine work more challenging. While the unit had a displacement of 4,200 cubic centimeters, or 253.6 cubic inches, this size alone did not guarantee consistent power. On thick or sticky soil, during long climbs, or when towing large implements, the tractor would slow down unpredictably, forcing farmers to constantly adjust speed and gears. Careful monitoring was required to avoid stalling, and prolonged use often increased wear on the engine, adding more stress to daily farm tasks. Power delivery added even more frustration for operators. Rated at 75 horsepower, the engine rarely maintained smooth output over extended work periods. Tractors often lost momentum on hills, in thick or sticky soil, or when towing heavier implements, forcing drivers to shift gears repeatedly just to keep moving. This inconsistent performance made ordinary tasks take longer than expected and increased fatigue during long hours in the field. Over time, operators also noticed that constant adjustments and stops put extra wear on both the engine and transmission, making daily work even more demanding. Torque also failed to help with heavy work. Although the engine could reach roughly 220 pound-feet, pulling force was inconsistent across speeds. Tractors often lost grip or slowed when carrying heavier implements, requiring constant attention from the operator. The inconsistency turned what should have been routine work into an exhausting chore. Fuel use became another problem over time. Under normal conditions, tractors returned around 10 miles per gallon, but demanding workloads reduced this efficiency significantly. Combined with the engine's constant need for monitoring and maintenance, fuel consumption made operating the D2264 more costly and tiring. Farmers quickly realized that this engine, despite its modern design, demanded far more attention than expected, turning even simple tasks into a challenge. Looking back, the MWMD 2264 is remembered mainly for the trouble it caused in daily farming. Its inconsistent horsepower, fluctuating torque, and fuel and maintenance issues left operators frustrated and slowed work. Number 7. Same 1004A. Every decade produces engines that look promising at first, but reveal their shortcomings under real-world conditions, and the 1004A was one of those in the 1980s. It was intended to power mid-sized tractors through routine fieldwork, yet operators quickly discovered that it struggled to deliver steady performance when pushed. Simple tasks like plowing, towing, or transporting heavier loads often exposed its limitations, and routine jobs became full of small challenges that added up over the course of a long day. Farmers quickly realized that they could not simply start the tractor and leave it running, as the engine demanded constant attention to avoid stalls or unexpected slowdowns. The displacement measured 4,000 cubic centimeters, or 244 cubic inches, which should have given tractors enough strength for medium and heavy duties. On flat ground, the engine could handle work adequately, but inclines, sticky soil, or uneven terrain revealed a tendency to slow unexpectedly. Operators had to constantly shift gears and adjust speed just to keep implements moving at a consistent pace. Even routine plowing or harvesting could take longer than expected, turning what should have been a straightforward day into a series of stop-and-go corrections. Rated at 80 horsepower, the engine frequently failed to maintain momentum during extended work. Torque reached around 260 pound-feet, yet heavy loads or low-speed conditions often caused a sudden drop in pulling power. These fluctuations left tractors sluggish and made even small hills a challenge. Operators reported having to make frequent adjustments to avoid losing speed or stalling, which added frustration and fatigue. This inconsistency meant that long days in the field required far more attention than with other tractors of similar size. Fuel efficiency was another weakness. Under moderate conditions, the engine delivered roughly 11 miles per gallon, but this number could drop sharply when the tractor was under a heavy workload. Farmers often needed to refuel more frequently than anticipated, and combined with the engine's finicky nature, this increased operating costs and reduced daily productivity. Maintenance demands added to the burden, as oil leaks, worn seals, and minor breakdowns were not uncommon. Even small repairs required extra time and attention, turning simple upkeep into a constant concern. Ultimately, the 1004A earned a reputation more for frustration than reliability. Its uneven power delivery, inconsistent torque, and high maintenance demands made it difficult for operators to trust the tractor over long workdays. Even with its European design and modern intentions, the engine could not escape the practical limits of daily farm work. By the end of the season, operators knew that the 1004A required vigilance, patience, and a lot of extra effort, serving as a reminder that impressive numbers on paper do not always equal dependable performance in the field. Number 6. Allis-Chalmers 433Ti. Some engines arrive with high expectations, promising both power and reliability, but the Allis-Chalmers 433Ti quickly revealed that raw specifications don't always translate into dependable, real-world performance. In practice, operators discovered that the engine demanded more oversight than initially anticipated. Tasks that should have been straightforward, like hauling or field cultivation, often highlighted the engine's shortcomings rather than its strengths. Even routine field work became a test of patience and skill, as the 433Ti required constant attention to keep implements moving efficiently, particularly under challenging conditions. The engine's displacement was 3,300 cubic centimeters, or 200 cubic inches, paired with a turbocharger intended to boost low-end torque. While these numbers seemed competitive, the engine's delivery was uneven under load. Steady performance on flat ground could quickly deteriorate when tackling hills, soft soil, or heavy implements. Sudden drops in power forced frequent adjustments to speed and gears, slowing workflow and increasing operator fatigue. Even short, routine jobs could require significantly more effort to complete. Rated at around 75 horsepower, the 433Ti often struggled to maintain momentum during extended work. Torque, hovering near 240 pound-feet, could be unreliable at lower speeds, and the turbo system sometimes worsened heat issues under prolonged strain. This combination of factors made consistent, efficient operation difficult, particularly during multi-hour field sessions. Fuel economy was another area where the engine's performance failed to impress. This high fuel use increased operating costs and forced operators to carefully plan each task to avoid delays or wasted resources. Under moderate workloads, the tractor could reach roughly 10 miles per gallon, but efficiency declined sharply when towing heavy implements or working in demanding soil conditions. Add to that, the engine's maintenance demands turbo servicing, injector checks, and monitoring for overheating, and it becomes clear that operating the 433Ti required observance. This engine became known less for its raw power and more for the operational headaches it imposed. Even routine tasks could become time-consuming and exhausting, as operators had to constantly adjust and monitor the engine to keep it running smoothly. While technically modern for its era, the engine's inconsistent torque, temperamental turbocharger, and relatively high maintenance demands meant that a tractor that appeared capable on paper could quickly turn into a source of frustration in the field. For operators, the Allis-Chalmers 433T served as a reminder that specifications alone do not guarantee performance, and that real-world reliability often requires more than just horsepower numbers. Number 5. International Harvester D358. The D358 from the 1980s was built to be a strong engine for medium to large tractors. It was meant to handle heavy work, carry big loads, and keep running under tough conditions. Farmers soon discovered, however, that it needed constant attention to keep working properly. The engine's power could be uneven, and during long hours in the field, small problems often became bigger issues. Drivers had to adjust speed and gears frequently, and the engine sometimes struggled with heavy loads or rough terrain. These challenges made even normal tasks take more time and effort than expected. For starters, the displacement measured 5,900 cubic centimeters, or 358 cubic inches. In theory, this size should have been sufficient for consistent medium-duty work. In practice, though, the engine frequently struggled to maintain steady output. On flat terrain, it could keep pace, but when faced with inclines, dense soil, or heavy implements, power dropped unexpectedly. This forced operators to adjust throttle and gears continually, making simple jobs much more time-consuming. The rated horsepower was 110, while adequate for moderate tasks. Prolonged plowing or towing could reveal limitations. Tractors occasionally lost momentum, requiring operators to slow down or shift repeatedly to prevent stalling. Over time, these interruptions made fieldwork more labor-intensive and increased fatigue, especially when completing multiple consecutive tasks. The engine often struggled under heavy work, especially at low speeds. With roughly 260 pound-feet of torque, it sometimes failed to provide a steady pull, and when handling heavier equipment or uneven ground, the tractor could hesitate, forcing operators to constantly adjust and keep work moving. Fuel consumption added another complication. Under moderate workloads, the engine averaged about 6 gallons per hour. Heavy field work, however, pushed consumption higher, reducing efficiency and increasing operational costs. Combined with regular maintenance requirements, including monitoring for overheating and servicing injectors and fuel systems, the D358 demanded much more attention than expected. The turbocharged system, while meant to boost performance, sometimes contributed to problems. Heat buildup could worsen oil and coolant issues, and improper maintenance could lead to further performance drops. Operators found themselves checking fluids and inspecting components far more often than with other engines of similar size. In the end, the International Harvester D358 earned a reputation for causing headaches rather than inspiring confidence. Despite having solid displacement, horsepower, and torque on paper, its uneven power delivery, tendency to overheat, and frequent maintenance needs made it a challenging engine to run smoothly. While technically capable, it demanded careful attention during everyday tasks, showing that even engines from well-known manufacturers can fall short when it comes to reliable, real-world performance. Number 4. Ford 6.6-liter turbocharged. Some engines generate high expectations with their size and turbocharged design, and the Ford 6.6L turbocharged seemed ready to deliver. It appeared capable of handling demanding mid-sized tractor work, moving heavy loads, and tackling tough tasks. On the ground, however, the engine showed several shortcomings, including a tendency to overheat during extended use, and operators quickly discovered it needed careful attention to maintain consistent, reliable performance. Its displacement was 6.6 liters, or 401 cubic inches, giving it enough power for tough jobs. In practice, however, long periods of work often led to overheating and fluctuating output. Continuous tasks, like hauling heavy equipment or long hours in the field, showed the weaknesses of its cooling system. Operators had to keep a close eye on engine temperature and adjust work as needed to prevent sudden drops in power and efficiency. The engine seemed capable of typical mid-sized tractor work, but its power delivery was often uneven. Rated at 156 horsepower, it sometimes struggled when pulling heavy equipment or climbing hills, causing the tractor to lose momentum. Operators had to adjust speed and gears frequently, which slowed progress. Over longer work sessions, this unpredictability added strain and fatigue, especially when making multiple passes or working in challenging soil conditions. Keeping a steady pace could be difficult, especially at low speeds, because torque was not always reliable. Under normal operation, it reached roughly 300 pound-feet, but the turbo system added extra complexity. Failures in the turbo or related components could further reduce usable power, making it challenging for operators, particularly those unfamiliar with the tractor's quirks, to maintain consistent performance. Fuel efficiency was another area of concern. The engine consumed about 7 gallons per hour under normal tasks, but heavy fieldwork quickly increased consumption, affecting both efficiency and operational costs. Combined with the engine's frequent need for monitoring and maintenance, the 6.6-liter turbocharged became more demanding than anticipated. Despite its power, the engine often required careful attention to avoid performance dips and mechanical stress. Operators needed to keep an eye on cooling, fuel, and turbo systems throughout the day. While it could handle moderate workloads adequately, extended or heavy-duty tasks exposed its weaknesses, making it a challenging engine to rely on consistently. The tractor's promise of robust performance was undermined by real-world demands, showing that even turbocharged engines are not immune to operational limits. Number 3. Cummins NTA-855-A310. The Cummins NTA-855-A310 quickly earned a reputation as a robust engine built for large tractors, yet it also showed that even the most powerful engines can have vulnerabilities. Engineered to tackle demanding tasks, including hauling heavy equipment, towing substantial loads, and handling extended hours of farm work, it boasted impressive specifications and raw power. On paper, its numbers suggested a machine capable of meeting the toughest demands. In practice, however, operators soon realized that this engine needed careful monitoring, regular upkeep, and skilled handling to avoid performance drops and reliability problems. Without attention, extended or intense workloads could expose its operational weaknesses, proving that sheer size and power alone do not guarantee consistent performance in the field. Handling massive implements was possible, but it came with challenges in cooling and fuel management. With a displacement of 14 liters, or 855 cubic inches, the engine had the raw capacity for heavy work. During extended operations, overheating could occur if the radiator or turbo system wasn't carefully monitored, and demanding tasks sometimes caused sudden drops in power and efficiency. Rated at 310 horsepower, it was more than sufficient for large-scale field work, yet the engine's power delivery could be uneven. Under prolonged use or steep inclines, tractors occasionally lost momentum, requiring operators to adjust gears and throttle frequently. Maintaining steady forward movement demanded continuous attention, particularly when the tractor was fully loaded. Torque reached around 800 pound-feet, but even this massive figure did not guarantee consistent performance. At lower RPMs, the pull could falter, particularly under heavy loads or in sticky soil. Operators needed to remain alert to prevent stalls, making long field work more physically and mentally demanding. Fuel consumption was significant. This high fuel use not only increased operating costs, but also demanded that operators plan work carefully to avoid downtime or inefficiency. The engine burned roughly 15 gallons per hour under heavy workloads, and frequent monitoring of injectors, turbochargers, and the cooling system was necessary to maintain reliable operation. While capable, the Cummins NTA-855-A310 required detailed attention to keep its performance consistent. Even the Cummins NTA-855-A310, with its impressive size and horsepower, proved that raw power alone doesn't guarantee dependable performance. Despite its massive displacement and torque, real-world use revealed weaknesses in cooling, fuel delivery, and consistent power output. Operators quickly discovered that the engine required careful maintenance, close attention, and skilled handling to function properly. Number 2. Case 504 BDT. Big, bold, and marketed as a high-performance diesel, the Case 504 BDT promised to handle medium to heavy fieldwork with ease. Its turbocharged design suggested strong pulling power, and on paper it seemed capable of meeting the growing demands of mechanized agriculture in the 1980s. From the outside, it appeared sturdy and modern, a machine ready to tackle long hours of plowing and hauling. But in real-world use, the engine revealed several weaknesses that operators quickly learned to navigate. Its weight and size also made maneuvering in tighter fields more challenging, adding to the daily workload. The displacement measured 8.3 liters, or 504 cubic inches, giving it respectable size for tractors of the era. The engine was intended to deliver steady performance across routine farm work, yet when loaded with implements or climbing gentle slopes, power delivery often became inconsistent, making operators constantly adjust speed to maintain workflow. Operators noticed sudden drops in speed, which meant constantly adjusting gears and throttle just to keep the tractor moving. Tasks that should have been straightforward became longer, more demanding, and frustrating. Many operators reported that even minor terrain changes could expose the engine's limits, forcing them to remain alert throughout the day. Rated horsepower hovered around 125. While enough for average duties, pushing the engine for extended plowing or heavy transport revealed a lack of reliability. Torque, roughly 300 pound-feet, often faltered at low speeds, causing the tractor to stall or lose momentum unexpectedly. Even experienced operators found themselves spending more time managing the engine than focusing on the work at hand. The constant attention needed sometimes slowed overall field productivity, especially during long harvest days. Fuel consumption added to the engine's difficulties. Under moderate use, it burned close to 7 gallons per hour, but hard field work and extended plowing runs could spike consumption significantly. The turbocharger, while designed to boost power, required frequent monitoring, and maintenance of fuel injectors, pumps, and coolant systems became critical to prevent sudden failures. Ignoring these small tasks could quickly lead to larger, costly repairs. Over time, this engine developed a reputation for frustration. Its promising specs did not always translate into reliable field performance. and operators quickly realized that long workdays demanded vigilance, patience, and constant intervention. While capable in short bursts or lighter tasks, the engine often struggled under heavier or prolonged workloads, reminding everyone that even well-designed engines can falter when real-world demands exceed their limits. Many farmers eventually learned to plan tasks carefully, breaking work into shorter periods to avoid overtaxing the tractor. In the end, the 504 BDT served as a reminder that high performance requires not only power, but also careful management in the field. Number 1. John Deere 955 V8. The John Deere 955 V8 was a powerhouse in concept, designed to dominate large-scale fieldwork with a massive 8-cylinder block. Its sheer size and V8 configuration implied superiority in towing, heavy-duty transport, and handling large implements with ease. At first glance, it seemed capable of tackling extended hours of work without trouble. But once the tractor hit the fields, its real-world behavior revealed a long list of operational headaches, from temperamental power delivery to high-maintenance demands, that operators quickly learned could not be ignored. Its weight and bulk also made controlling in tighter plots bulky. Displacement measured 15.7 liters, or 955 cubic inches. The large engine promised substantial torque and theoretically smooth power, yet operators found it inconsistent under real working conditions. Pulling wide or heavy implements, navigating slopes, or working in soft or uneven soil often exposed sudden drops in power, forcing constant adjustments to throttle and gears. The V8 design required precise handling and frequent maintenance to prevent stalling, overheating, or sudden torque loss. Some operators also reported issues with vibration and rough idling under partial load, which could quickly cause fatigue over long shifts. Horsepower was rated at 370, but maintaining this output for extended field sessions proved difficult. Torque peaked near 450 pound-feet, theoretically sufficient for demanding tasks. Yet inconsistencies in turbo boost, uneven fuel injection, and occasional injector clogging meant that at low speeds, the tractor could falter or jerk unexpectedly, leaving operators scrambling to maintain both momentum and implement control. The engine's responsiveness could vary significantly, depending on temperature, soil conditions, and load, creating an unpredictable work experience, even for seasoned operators. Fuel economy added another layer of complexity. Under moderate work, it averaged about 8 miles per gallon, but heavy use quickly pushed consumption higher, increasing operating costs. The turbocharged V8 demanded constant monitoring of oil pressure, coolant levels, and fuel delivery. Even small oversights could escalate into overheating, turbo damage, or injector failure. Operators also reported that frequent service intervals and higher than expected spare parts requirements made managing this tractor more demanding compared to other machines in the same class. Despite the V8's raw potential, the John Deere 955 earned a reputation for unpredictability and high upkeep. Operators discovered that long hours in the field required constant attention, careful balancing of speed, load, and maintenance, and proactive problem solving. While it could handle heavy-duty tasks when managed correctly, its quirks including uneven power, high fuel and oil consumption, sensitive turbo systems, occasional mechanical vibrations, and extra strain on supporting components made it a challenging machine to operate efficiently. The 955 V8 stands as a clear example that even premium brands can produce engines whose theoretical performance does not always match practical reality in demanding agricultural conditions. It serves as a reminder that power and size alone are not enough. Real-world reliability often demands careful planning, skilled operation, and thorough upkeep. Engines that promised the world but delivered headaches. These 1280s tractors proved size doesn't equal reliability. Wrenches got more action than the tractor seats, and even simple jobs became a test of patience. Seen a model that should have made the list? Drop it in the comments, hit like, and subscribe for more engine headaches.